All right, everyone, we're going to go ahead and get started now. I appreciate everyone taking time out of your day to join us for today's presentation. Today's webinar is entitled Combustion Theory and the Combustion Analyzer. And on behalf of the team here and everyone at BACRAC, we do want to thank you for taking your time out of your day to learn more about combustion theory. Before we get started, I want to run through a few housekeeping tips to help you get the most out of today's presentation. This is a Zoom webinar, and all attendees will be muted throughout the presentation. We do encourage you to use the question and answer chat box, which you should locate at the bottom of your screen. We do have a member of the team who will be answering questions throughout the presentation in order to allow Jim to continue through everything he needs to cover. We will not be providing slides or a recording of today's presentation, as we will be offering CEUs for the presentation. As I mentioned, and as you probably saw in most of the emails, we are pre-approved for 2 hours of NATE CEUs for today's course. We will also be providing a certificate to all attendees as a proof of your participation. So if you are seeking certification from an organization that offers reciprocal credits, you should be able to use that certificate to do so. If you have any questions, please feel free to email me directly, and my team and I will do what we can to help. Also, I know we have some groups who have multiple technicians watching around a single computer. If you could, please just let us know via the chat feature who's in the room so we can make sure that everyone gets credit for being present. Now to introduce our presenters, Jim Burke is going to be presenting today. Jim is a graduate of Clarion University, former Marine, and a certified boiler operator. Jim has worked in the HVAC industry for 39 years, and a point of pride, I think 28 of those has been with BACRAC. So we're very lucky to have Jim here with us today to share all of that information that he's accrued over all those years in the industry. In support, we'll have Kevin Dorwart. Kevin is our Western sales manager, and you also have myself handling some of the Q&A as well. Jim, I know we've got a full plate, so if you want to go ahead and take it away from there.
Okay, thank you, Matt, for putting all this together and doing the marketing, and thank you, Kevin, for having my back on the questions, and thank you everyone out there for taking time out of your day to listen to this Zoom seminar. First slide I want to do here is talk about the general guidelines and best practices. So this is really guidance given here is taken from best practices within the HVAC industry. And it may not be appropriate in all situations in the field. So always refer to state and local codes, your authorities of jurisdiction, manufacturer's manuals, specifications, and your own training and experience. Okay. So as you saw from my picture there, you can see I've been around for a while, and I've seen a lot of combustion seminars and read some books on seminars, some way better than others. Some can definitely put you to sleep, and they go way deep into combustion. And I probably in my earlier days did ones that could probably put you to sleep. I know when I would turn the lights on, I see some eyes being kind of like opening up. So what I've tried to put together here is a seminar that's a little more interesting. So I want to go over combustion theory and the combustion analyzer. So we'll start off by talking about history. And in that history, I'll talk about how BACRAC came about being, which is part of that combustion history. I'll talk about combustion basics, how combustion analyzers work. And this is regardless of whether you have a BACRAC combustion analyzer or someone else's. I'm not trying to push BACRAC down your throat. though I do show, our products because my competitors didn't send me any of their slides, and I am a salesman, so I will show you features of our products, but it lets you know what's new in combustion analysis, and then I'll show you how and where to test. Then we'll talk about carbon monoxide, symptoms of it, poisoning, how it gets in your system, how come you have two CO readings on your combustion analyzers? So one's CO raw and one's CO air free. You have to know your code and which one you're reading. And then typical troubleshooting with an analyzer, we'll go over appliance reading, typical ones. We'll go over testing for carbon monoxide. So we'll do like a mock going through a house, look at all the appliances. And one thing I always notice about some seminars, people walk out and go, boy, was that entertaining, but I have no idea what to do. So I'm hoping from mine, at least I'll show you the problems and show you how to fix it. We'll go over how you can use a cracked, your combustion analyzer to check for cracked heat exchangers. And then show you some examples in the field. So let's get started here. Backrack is a Pittsburgh-based company. We've been a company for 110 years. We've been in Pittsburgh since 1909. So we're leading edge in technology for residential, commercial, and industrial markets. We're ISO certified, and most of all, we're a USA manufacturer and designer of instrumentation. Backrack has really grown a lot in the last several years through acquisition of other companies. Where headquarters are still here in Pittsburgh, but this division that I work for, and Kevin, is a portable instrument division, and we focus on what we do best. So it would be combustion analyzers and leak detection, handheld leak detection. When we do handheld leak detection, we do it for refrigerant and combustible gas. And anytime we do combustible gas, our instrument's intrinsically safe in our portable division. So Matt's going to take a quick poll here. Good time to get a cup of coffee.
Hey guys, we want to get a poll to see who we have attending today. So if you could just let us know what type of applications that you typically work on. Residential, commercial, or a mixture of both? Great. It looks like we have a lot of folks on the call today who either do residential work or a mixture. Give it a couple more seconds here, and we'll close that poll. All right. Yeah, as you can see, 42% of you are working primarily in residential, with just behind that, 41% working in a mixture of both. Okay, Jim?
Okay, so that's interesting. This is, okay, I'm locked. Can you take this poll screen off? Matt?
Yes. There you go, Jim.
It's not on. It's a new age with Zoom meetings here. Yeah. So.
All right, bear with me, guys. I apologize.
Okay, I got it.
All right.
So let's. That's interesting. This is really heavier residential, but I did have some commercial slides, and since so many of you are commercial, I'll throw in some tips on commercial boilers as well. So I do kind of mix the whole thing up. So when we talk about combustion, the history of testing, Backrack, how Backrack came about is a big part of it. So I'm always interested when there's a seminar by somebody. How did that company start? So how Backrack started was a young German immigrant named Herman Backrack came to Pittsburgh, Pennsylvania in 1909. Herman started a little company importing air velocity meters for the coal mines of Western Pennsylvania and West Virginia. The company was doing great until about 1914 when World War I broke out in Europe. And though the United States wasn't in it yet, there was an embargo going both ways between the United States and Germany. So Herman couldn't get his air velocity meters from Germany anymore. By this time, he's a United States citizen, so he didn't really care. It forced him from going to be from a distributor, much like the HVA distributor you go to be a manufacturer. And it was actually a very great time because it was doing the Industrial Revolution. Pittsburgh was booming with the steel mills and the coal and the iron ore and all the rivers, so you could ship all these ingredients into the mills and out of them the goods. So he went out and found the best engineers he could, and made an instrument company that was really very innovative for handheld instrumentation. Then came, but there's still no formula at this time for combustion efficiency. And around 1928, Dr. Konzo from the University of Illinois came up with a formula for combustion efficiency. Prior to this, the boilers had been around for over 130 years. There was no way to tune them up, but what they were trying to do with boilers was just trying to keep them from blowing up. And a boiler a week would blow up from 1850 to 1920. Actually, before 1850, it was a boiler would blow up every 3 days. So these technicians like yourself ever just try to get these things to keep running and not blow up. A lot of codes came in the early 1920s about structures of boilers and the parts that were put into them, and the quality. But there was no formula for combustion efficiency. 1928, Dr. Konzo comes up with this formula, and he said, okay, so if we took a stack temperature where the boilers at the flue, right, coming out of the boiler right here, it's called the breeching where the stack meets the boiler. If we took a stack temperature of that, just for argument's sake, let's say it's 480 degrees. We minus the air going into that boiler, and this would be true for a furnace, water heater, whatever, because we didn't heat that combustion air going into that boiler. So if that was 80 degrees going in there, and this is 480, we subtract the 80 from the 480, would be 400 degrees net stack temperature. Then if I take a sample of oxygen out of there, then I can just put it on a cross tabulation chart. Say this much oxygen, this much net stack temperature is this much efficiency. We still do that today. We still use Konzo's formula today. It's the best way to do combustion analysis. Okay, so going back to this other chart then, so it's great. Now people could do combustion efficiency on a boiler. The problem is to check for oxygen, the only way to do it was this elaborate set of glass tubes called an ORSAT, invented by a French chemist named ORSAT. They're extremely expensive, high technology in 1928. And no one in their right mind was going to take a set of these expensive tubes, laboratory grade, down to a boiler room. So that's when Bachrach, Herman invented this product here. It's an hourglass. It was called a Firite, and it was a portable ORSAT that you could take into a boiler room. So you could pump a sample out of the flue here, pump this 20 times, and you turn this upside down several times. It would mix with this fluid, and it would come up and give you a direct concentration of either CO2 or another one would do oxygen. And then you would take your stack temperatures and have a little chart, and you could do a combustion efficiency. He called it Firite because it made the fire right. So we still use that name, Firite, today in a lot of our analyzers in our marketing. So and then we came up with Flow-Rite and Draft-Rite and other Rite instruments. So we really didn't have too much competition probably for the next 50 years. So when people think of combustion, a lot of times they just think of Bachrach. Let's talk a little bit about the analyzers here, or combustion analyzer. Let's talk a little bit about the theory first. Combustion's combustion. So whether it's in a furnace or a boiler or a water heater, it's basically the same. The gases are the same. My purpose here is to show you the gases that are made in combustion and what those gases tell you. Okay, so we all know the combustion triangle here. You bring in fuel in a usable form, and all the fuels that we burn are hydrocarbon fuels, so they have a hydrogen element and a carbon element. We mix it with room air, and 20.9% of room air is oxygen. then we have ignition. And right after that, which is a little heat. And then after that, the heat from this source can be the ignition. Okay. So here's our, like I said, this would be good for any appliance, but we're going to use this boiler because I like boilers. So we're bringing in fuel and we're bringing in air and we're mixing it in here in this power burner, and it's shooting it into, it's called a Morrison tube that goes down here. It's a combustion chamber. And we have our carbon element and our hydrogen element. We're mixing with an oxygen atom, and the rest of room air is basically nitrogen. And a chemist would argue maybe there's a little bit of 1% of other gases. Okay, so we're going to bring them in here. We're going to have a chemical reaction, which is our combustion, and then those gases go through here. A boiler is really a vessel of water under pressure that makes steam. Okay, oops. And so the gases go out, and we're gonna have some different gases coming out. So we take the carbon element, we mix it with an oxygen, and we make CO2. So every time you have combustion in a boiler or in any appliance, you make CO2. This is not carbon dioxide. This is carbon dioxide. Okay. And the more efficient you run the boiler, the more CO2 you make. So a lot of other countries are monitoring CO2. We do not monitor CO2 in the United States. And then we have hydrogen, which is H2, and we mix it with a half an oxygen, and we make H2O. So that's water vapor. So every time you run your boiler or furnace or fireplace, every time you smoke a cigarette or light a match, you make water, okay? You may notice coming out of the tailpipe of your truck, water comes out sometimes. You make water inside your engine, okay? So that's why in a combustion analyzer, we have a water trap. We want to trap that water before it gets inside our instrument, okay? And then we have heat, okay? So the process would be, if we could perfectly bond all these fuel and air molecules, we'd have CO2, water vapor, and heat. And this seminar will be over. You get about a quarter NATE credit, and we could all go home. But our appliances that we make, none of them are 100% efficient, at least in the fuel burning ones. And so what we have, if we put in just the right amount of fuel and just the right amount of air in there, which would be perfect combustion, which they call stoichiometric, we would be throwing raw fuel at the stack. We'd be making a lot of carbon. We'd be making a lot of carbon monoxide. We'd be throwing raw fuel at the stack. And you can imagine this would not be good. So what we do in this process, in order to bond those fuel molecules that are not being bonded, we add more air than we really need, okay? So this extra air you add to the process is called excess air. And I know there's a 16-page white paper out there that talks about excess air, and I heartily recommend it if you can't go to sleep at night. If I was going to write one, I would just say this. Excess air is the extra air you add to the combustion process to ensure complete combustion. So excess air is the extra air you add to the combustion process to ensure complete combustion. So we bonded this, here it's a methane, CXHY, a methane molecule with an oxygen. So now we're not throwing raw fuel at the stack. What is happening is, we have complete combustion. It's no longer perfect because now we have all these extra molecules of oxygen, they're the atoms. And what they do is they go up the stack, and we've heated them up and we're sending them outside. So it lowers your efficiency. Not only do we have a big bubble of oxygen, we got a bubble 4 to 5 times bigger of nitrogen, okay, that we're heating up and sending outside. So we basically, we want to add enough oxygen to bond the fuel molecules, but not so much that we're lowering our efficiency. And that's what combustion efficiency is all about, okay? So now coming out of the stack, we're going to have oxygen in a bigger bubble of nitrogen that we've heated up, okay? But sometimes things go wrong, and we'll take a carbon element, mix it with a half an oxygen, and we make carbon monoxide. It's CO. That's a deadly, colorless, odorless gas that humans have no way of detecting, and it's a very harmful for us. It can be lethal. So we want to monitor that. And then if you're in oil and you're up in northeastern North America, both Canada and New England, you may make smoke, in your process. So we do have a product for that. If you have if you're doing oil and you're going to take a combustion test, you always want to take a smoke test first, because you don't want to run that soot through your boiler or your furnace. 1/16th of an inch of soot will lower your efficiency 8%. So what you want to do before you take a smoke test, we invented the True Spot smoke tester back in 1947 in conjunction with Shell Oil. So what you do, I know it looks like a bicycle pump here. You pull this probe out here, you would put it in a stack, you would put in a piece of chemically treated paper there. So you can't use a bar napkin, you have to use our chemically treated paper. You pump this 10 times. You have to be full strokes, because this is a calibrated flow we want to go through here. And then you take that paper out, and it'll have a little dot, and it'll be discolored. And you put it up against this Ringelmann chart here. And you really just want to be at 0 or 1. You just want trace smoke. You want to go by your burner manufacturer specifications. Almost all of them are trace smoke and or no smoke. And if it's not there, if it's a higher number, you want to work on set that so it is lower, and then you're not going to soot up your oil burner, or you're not going to send that soot through your instrument. Okay, getting back to these gases. So we talk about CO2, water vapor, heat, oxygen, nitrogen in the stack, and possibly carbon monoxide. Hopefully no smoke. But the two elements we want to look at here are the oxygen and the heat, and this is what's going to give us our combustion efficiency. So we have an oxygen sensor in our combustion analyzer that's going to measure that oxygen. We have a thermocouple in our probe that's going to measure the temperature in that stack. And then inside of our combustion analyzer, we have our thermistor that measures the room temperature. So it subtracts that room temperature from the stack automatically, takes the oxygen reading, and it calculates combustion efficiency for you. We'll go over how to do that later on. I'm going to just graph these gases briefly here, just to give you an idea of how they relate to each other. So this is called the stoichiometric chart. It's really a chart that will let me graph the gases. So on the left-hand side here, these are percent by volume gases. So this chart would go from 0, 2, 4, 6, 8, 10, and probably around to 14. I don't have those numbers on here because this chart is different for every different fuel. So you'd have a different one for number 2 fuel oil, number 4 fuel oil, or 6, you'd have a different one for propane, natural gas, what have you. So we don't put numbers on the side. And the bottom is the air, okay? What perfect combustion would be 100% of just the right amount of air. We call that stoichiometric, okay? And so we learned from what I said so far, we can't be at perfect combustion. Our appliances won't perfectly bond those fuel and air molecules. So we want to add more air to that process, that excess air. So we bond those fuel molecules, and that's what would be on the green here, okay? And this green would be 100% of just the right amount of air. Here, 120 would be, I'm using 20% more air than the theoretical 100%. Sometimes you'll see things written or an analyzer will just say 20%. Sometimes in this chart I have 120. It's saying the same thing, 20% more than the 100% of the theoretical air you need. 40% more would be the 140, 60, and so forth. So we want to be on this green side when we do our equations. Over here so we have more air than we theoretically need for combustion, but we need it for complete combustion. Over here on this sort of rose-colored side, rose for combustion flame, it's called the fuel-rich side. We have more fuel than we need in combustion. It's fuel-rich. So here we only have like 80% of the air that we possibly need. Sorry, my pointer here is acting up. So we only have 80% here, 60%. In this side, if you're a little bit older, you may remember when we had um, lawnmowers. I remember when we had cars this way, but lawnmowers used to be you would pull a choke to get it started, and soon we will start snow blowers in some parts of the country. You have a choke on, you pull that choke, and you're over in this rose-colored slide. When you pull that choke, you've cut off the air. You're fuel rich. It's a good way to start it, and it sputters and coughs and shakes all over the place, but it gets started. You can't cut your grass or snow blow your driveway with it running over here like that, but you got it started. Then you pull that choke back in and the air is going good, and you're going to be running back over here. Okay. So now we're going to graph some gases that we would have on this chart. The first one I want to look at is oxygen. So oxygen's only going to be on the excess air side in the stack as we add that excess air, which is oxygen, into the combustion process. Okay, so we're going to be right over, we're going to start adding. The more we add, the higher oxygen concentration we add, the more our excess air number is. And the lower our CO2 number is. CO2 is on here, and it's diluted by oxygen, has a direct relationship on the excess air side. So I could be, after work, I could be drinking a Frosty with some other boiler technicians, and I could say, I like to set my boiler at a certain percent CO2. And another one say, well, I like to do this percent oxygen right here. Another one say, well, I like to do this at 100 to 100% excess air. You all said the same thing. So we're doing a combustion analyzer. We measure oxygen. We go up, we calculate CO2, we calculate excess air, and then we calculate efficiency. So I really like to read oxygen. I'm not so concerned about the reading of excess air or CO2 because I know my oxygen is actually just calculating those on an analyzer. The reason we don't do CO2 and we do oxygen is because CO2 is on both sides, as you've noticed on this combustion chart. And I could be reading CO2, I could be reading 8% CO2, and I actually don't know which side of combustion I'm on. In the earlier days, there was a boiler man called Harley Payne, pretty famous down in North Carolina. You guys down there may know him. And he went into a factory, called him up. It was actually a clothing factory down there, and they had many boilers, and they were using an awful lot of fuel. And what had happened is one of their boiler men, or one of the people that worked for the facility, went to the facility manager, said, I know how to tune up boilers. And they said, hey, have at it. And he tuned them up based on CO2. And after he tuned up all the boilers in the next 3 months, they spent over $10,000 more on fuel. And so they took Harley in, and he had back rack equipment. He went in, every one of the boilers was running over here. Okay, so the back rack equipment, he worked on them and had them bring them over here, and they saved tens of thousands of dollars after that. So there is another company that uses CO2, but they have to work out how they're going to do their combustion efficiency. I think they do it CO2 to CO. So if you should always know on the combustion analyzer, if it's not a back rack, which type of sensor that you have when you're measuring combustion efficiency. And then I would put an overlay on this. As I talked about, this is a percent by volume gases here, your CO2 and your oxygen and that. Well, this green line I put in here is carbon monoxide, that deadly color soda gas we will talk about later. And we can't do it in percent by volume. 1% by volume equals 10,000 ppm of any gas. So if we measured CO by percent by volume, the time the meter read 1, everyone would be probably passed away in that building. So we do it in something a lot lower called parts per million, ppm. Like I said, 1% by volume of any gas equals 10,000 ppm. So 8% of CO2 would equal 80,000 ppm. So here this would be an overlay, and we're reading CO and ppm, very low quantity. In other words, if the back rack building I showed you, if we put 1 million ping pong balls in it and they were white, and we took 50 out and put in 50 blue ones, it would be, those blue ones would be 50 parts to that million. Very, very low quantities. which CO is very high over here because we have incomplete combustion, okay? As we get into stoichiometric, we still don't have good mixing right here. And then every appliance is different. So it depends on the appliance. That's why this is a dotted line here, okay? But it gets a lot lower as you add in the oxygen. And then as you add too much, you get way out here. I mean, you really shouldn't be because you'd have low efficiency, but you add too much oxygen in there, you're going to dilute the sample and you're going to have incomplete combustion again, start making CO. So we really want to be in this area here called our sweet spot. We have recommendations in your boiler, your furnace manufacturer has recommendations on where you should be, okay? So let's say I put my analyzer on here. If you have an analyzer, you recognize something like this, regardless of whose you have. So this would be a boiler or furnace that's really out of spec. So your oxygen is really high. You shouldn't be running up here. So you have 10% oxygen. Your efficiency is low. It's at 78%. CO is low, but your stack temperature is high. Okay. So let's say this was a boiler. Let's work on your gas pressure, make sure that's correct, and then work on an air damper to bring down that oxygen. So here it's showing the oxygen's high. Your CO2 goes down, your efficiency goes down, excess air goes up. So look, your oxygen goes up, your efficiency goes down. So we're going to bring down that oxygen either by correcting your fuel pressure or your air. And where our analyzer was right here, this is where it's reading out here with all that excess air. And this line's going to start going this way. Your oxygen's going to start going down. Your efficiency is going to start going up. Okay. So let's say we brought it to, so this is kind of interesting. It shows the oxygen going down and your efficiency going up because we're going to take the oxygen down to 6%. Okay. That'd be dramatic. It's probably a boiler. Okay. So we took the efficiency from 78 to 83. Very good. It's going to save a lot of money on this fuel. Okay. CO went up a little bit, but still way within regulations. The important thing here is why taking that oxygen down raise your efficiency? It's because your stack temperature. It was at 470, we took it down to 390. So now we have 80 degrees of stack temperature that have gone into your system, okay? So you're using that 80 degrees of heat, okay? So on my personal analyzer, I like to set it up where I have oxygen, then I have CO, then I have stack temperature, and then I look at efficiency. And those four parameters, oxygen, CO, stack temperature, and efficiency, really gives me what I need to know here. Now we brought you this down to here. Okay, we're still within the sweet spot. If I kept on going, it would start making probably a lot of carbon monoxide. Okay. Actually, I was at a place out in St. Louis that makes beer, and their facility. This was the old days. It was one of my favorite sales calls, but it was probably 1983. And they had a big old boiler there. It was built in 1919. And they mixed it, pulverized coal mixed with a slurry of oil. And they shot it into this huge boiler. And the stack was 24 feet by 24 feet. So, you couldn't get a 12-inch probe in there. It had 2 feet of insulation around it. But these types of boilers have a tubing that comes down you can connect to, you make it tight, and you can work with your oxygen and CO. And in this case, I can't remember what the oxygen was, but the CO was over 1,000 parts per million. It was very low oxygen. So we actually had them add a little more oxygen to the process. Because it was a coal and an oil slurry, we didn't have the gas pressure. And they raising the oxygen, took it from just a little bit. The oxygen was 6.9, that's what it was. We raised it to 7.1, not that much, but it dropped it from 1,000 down to 400. Back in 1983, they said that was fine. They had a stationary there, engineer all the time that would work on that. So, interesting example of big old boilers. let's talk about how combustion analyzers work. We're going to take another poll here. A good chance to grab a cup of coffee and take your poll. So I guess they're asking here, I can't hear Matt, so he's asking if you own an electronic combustion analyzer. Just tell us yes or no. Just kind of interesting I like to see how many people in the seminar do. And it has some examples of some of our competitors. Just, that helps me if you have someone so I can help you explain those as well. Yeah.
And it looks like, Jim, we've got a good percentage of the attendees today do own an electronic analyzer. And give you a couple more seconds there to get our answers in. All right, thank you, everyone. And so, yeah, it looks like 84% of the attendees do own an analyzer, and almost 70% of you own a back rack analyzer. So we do appreciate that. And for those of you that don't own a back rack analyzer, there's still room in our hearts for you too.
Absolutely. I got to say, I love this crowd. It's probably the highest percentage of contractors that own analyzers that I've done seminar, and I've done hundreds and hundreds of seminars in my life. And thank you all for letting us know which one you have. Let's see, we're going to do this again here. Okay, so let's get into how combustion analyzers work. Okay, just as a doctor has pieces of equipment, a stethoscope and something to check your blood pressure now, and he's checking the health of your body. That's what a combustion analyzer helps you do on checking a boiler or furnace. We're going to check the health of that boiler or furnace. Okay. So here are the combustion analyzers that we have. You can see we're not going to go through the Orasat down there at the bottom. We actually still sell that Orasat today. Some of the oil guys buy it, but we mostly sell for environmental chambers. And then we have the three here that I'm going to talk about would be the Intech and Insight Plus mostly. And then we have the PCA 400. This one would be for really emission testing, a short-term analyzer for emission testing. And a lot of this market has been taken over with this PCA 400. Okay, so you can see we call it the FireRide Intech and the FireRide Insight Plus. PCA stands for Portable Combustion Analyzer here. So let's talk about the different markets where you would use an analyzer for each one. And if you did have an analyzer of competitors, they do the same thing. They have a certain instrument for each category. So the residential market is why we have an Intech. Okay, so that's the entry level. It's fantastic for doing residential testing. About 20% of residential market will buy up and buy an Insight Plus. A little more rugged on the bottom. It does higher percentage of CO. It does draft where the Intech doesn't, and then it has some. It's feature rich, I like to say, on the products that it have. They both do oxygen and CO testing. And then we have our commercial market. So the Insight Plus. So on the commercial market, you're talking about 10 million BTUs, boilers and down somewhere around that area. And you have your FireRide Insight Plus. Okay, we'll just call it an Insight Plus. And if you're only doing oxygen and CO, that's fine. Okay, that's a fine one. You're going to do draft as well on that. A lot of people use that one for the commercial market. If right now or in the future, you want to do not only oxygen and CO, but you also want to do maybe NOx testing, NO or NO2 or SO2 testing, SOx testing. You think you may in the future, you want to step into buying a PCA 400. PCA 400 is our newest instrument. We've come up with several years ago. It has a touch screen. You can add 2 more sensors into it, like I said. And if you really want to read high CO, like maybe you have engines, this would be the unit you'd want to use because it can go up to 40,000 parts per million. And if that's not enough, you have a higher range sensor that can go up to 80,000 parts per million. Way more than enough than you need. But some engine manufacturers, like maybe if you're working on a Caterpillar or a Waukesha engine, that would be the unit you want to buy, as well as bigger boilers, which I'll show you here. A big boiler like that, these are 25 million BTUs. You should definitely be using like the PCA 400. Okay, so let's concentrate on these three. I'm just going to kind of give you the features of what the entry-level units have. Like this one have a 2-year warranty on the oxygen sensor. We have a feature that's very unique to back rack, and only back rack has it, which is, well, I'm going to skip it. It's a CO reading at startup. So we can actually read CO at startup where everyone else would possibly not read it. What happens is when you start a combustion analyzer, so we have a oxygen sensor and a CO sensor here. You plug in your hose and probe, which we're going to go over in a little bit, and then we turn the unit on. We do not put the probe in the stack yet, and this unit is going to run from 30 to 60 seconds, and it's going to calibrate that oxygen sensor. Okay, we'll go over this in a little bit later. But it also does something unique in it. It zeros the CO sensor. Okay, well, that's fine. We're going to tell you later on about calibration on a CO sensor, and you want to calibrate it once a year. And it stays rock solid pretty much up there. You put 100 ppm on it or 500, it stays perfectly fine up there. But down around 0, they kind of move around a little bit. So it may say 0 today, next week it might say +1, a couple weeks later it might say -2, and that just kind of freaks a lot of people out. So what all manufacturers do is we say there's no CO here, this is 0. So you turn this on, it calibrates the oxygen sensor, and zeros the CO sensor. That's fine, except the problem may be there's CO in the building you're in. If there is, and say there's 10 ppm of CO in the building you're in, and you turn this on and it zeros to it, now when you see 10 ppm in a flue, it's going to read 0. If you see 20 ppm in that flue, it's really only going to read 10. So you're going to be off by whatever it zeros to. What if it was 30 ppm in that building? Now you're off by 30 parts per million. So Backrack has a feature. So the protocol is to go outside and turn it on if you think CO is in that building. And you turn it on outside, you zero the outside atmosphere. And that's fine. That's a great protocol. However, some cities, if you're doing work in cities, the ambient air could be 12 to 15 ppm outside. 12 or lower, 15 or lower. Or it could be 10 degrees outside, and I don't think anyone's going to walk outside. So we have a feature called CO manual. It's CO reading. It gives you the ability to read CO at startup without it at zeroing. So you go down in there, and the great thing about being a U.S. manufacturer and designed, we're just very easy to navigate our units. You just hit the menu button right here, and it'll give you a different tree trunk, of different readings. You go into one that says setup, and it'll go down to the bottom of setup. And next to the bottom, it'll say CO manual. I go up where there's fresh air, I punch that OK, and it'll zero that unit, that CO sensor, and then it will never zero it again. So now it's zeroed it in fresh air. And so now, if I go into that building where there's 10 ppm and I turn my unit on, it'll say 10. Everyone else will say 0. Okay. So it's a great little feature. If anyone, those people that didn't buy the back rack, you want to make sure you go outside and turn it on if you think there is CO in that building. If you own this back rack and you don't have that feature, you want to go outside. If you want to use that feature, you want to re-zero that in fresh air about once a month. The other thing that we have on these units is CO protection. So this unit here goes to 2,000 parts per million. The Insight Plus goes to 4. The PCA 400 goes, 20 to 40,000 or higher. But in the Intech where it does 2,000, and Insight Plus where it does 4,000, I get a call about once a year where someone said, I got this unit, I wanted to show it to my friends on a Friday night, and what they're doing on a Friday night, and they stick it in the tailpipe of their car or their truck, their Ford F-150, and then then they call me up and go, CO sensor doesn't work. I go, well, it did before you did that. A truck can make 60 to 100,000 parts per million. And maybe you're the facility manager and this is someone to work for you. So what we have now is CO protection. So you can do that same thing. Hit the menu button, go to setup, go the whole way down to the bottom, CO protection, and you okay that. And we give you the ability to start at 500. It'll go up by units of 100. And I can go up to maybe I want to do 1200. The code where I live is 100 ppm, so 1200 is more than adequate. And I hit OK, and I set it for 1200. If this ever sees 1200, say one of your employees sticks this in the tailpipe of a truck and it sees 1200, the pump shuts off. Or your processor you're working in sees 1200, the pump shuts off, and it just saves that CO sensor. And it's good for the CO sensor to protect it from seeing high concentrations anyway, because high concentrations deteriorate the life. We have the warranty here is 2 years. We have CO protection, CO at startup reading if you want to turn on those features. We have a replacement program, so we can send the calibration to you. You don't have to send it to us. We'll talk about that. And then we have a reporting app that we'll talk about later on that you can save you from having to buy a printer. So the Insight Plus has the same thing as the Intech, only it has a 3-year warranty. The CO goes up to 4,000 parts per million, and it has a lot of other features. One of them that I like is called TuneRight, and TuneRight is like a service assistant. You turn on TuneRight, you let it know, say maybe I'm working on an 80% furnace, or it can be a boiler as well. We have them in there in the program. And you run it, and it looks at the CO, the oxygen, and the net stack temperature, and it'll come up with, you always want to wait till you get up to steady state efficiency in these, and then when it tries to get it to steady state efficient, which you look by temperature, and if something's out of whack for that 80% furnace, like it's showing on that screen, where you're in the red, it's going to say you have a problem here. And then you can hit it and it might say, you have too much CO, maybe it'll tell you. And you say, well, what do I do? And it'll tell you, well, look at these 4 things. It's not saying this is what it is, but it's kind of gives you something to look at. It might say, look at flame impingement, look at dirty burners, maybe you're overfired or underfired, whatever. So it's like a service assistant you have in there. And it's also, this unit's a little more rugged on the bottom, and it does draft. And has that reporting app. These are the screens that are in the Insight Plus. So let's talk about all combustion analyzers. All of them have a display, they have a keyboard, they all can automatic zero the CO sensor, or you can have go into manual mode in ours and not zero it. You want to calibrate all of the CO sensors in all of them. They come up with magnet boots, and the reason they have a magnet on the back is so you can just put it against your furnace and it'll adhere to that furnace, your hands free. In a world of computers here, one of my very good friends when I was watching this dropped his analyzer one time, and he was talking on the phone. He set it up on his computer, and he wiped his computer because magnets in hard drives don't work out real well. We all found out that day, so he had to see if he could declassify, go to the government, and they had a program to try to figure out what was on his hard drive, and actually they couldn't. So it really actually wiped his computer. Be very careful of magnets in computers. But anyway, you have a magnet on the back here, so you can set it against your furnace or boiler. You can save readings on your unit. Okay, the Intech saves 10, the Insight Plus saves 100, PCA 400 saves 500 tests, and then we have our app that you can save on that app, which most people probably do today. USB ports transfer data to computers, or in our case, you can run off a line power. We are battery operated. Some of you out there have a unit that's rechargeable batteries. Okay, so let's show the units here. So you have a hose and probe. Okay, you can buy them with or without printer. Okay, here's your probe. You can get our Insight Plus comes with a probe stop. It's an accessory for the Intech. Here we have a thermocouple right here, and thermocouples read right at the very tip. So you want to put that in your process at the hottest spot in the stack, which is pretty much the middle. So you're going to be pulling a sample. You have a pump in your unit here, and a pump's going to be pulling a sample of gases around this thermocouple. The thermocouple is going to be reading temperature. And that thermocouple wire goes around here, goes up here, and it comes in this plug. You plug it into your instrument. The pump that's in your unit pulls the gases from this hollow tube through this hose, through the water trap, drops out the water, through a filter, which picks up the particulates, and into your unit, okay, for your gas sample. If it's a Insight Plus, you also then have a draft, a separate draft reading, because your draft sensor is separate there, okay? And here's what the bottom looks like on an Insight Plus. It's way more rugged on the bottom here. So this is where you could run offline power, download to your laptop. Here's where you plug in your thermocouple. You can buy an extra K-type thermocouple and do differential temperature if you wanted. Here's where you connect your hose for your gases. Here's where you connect for draft. You can't mix them up, they're different sizes. And if you wanted to do differential draft, you can put a tube on here and do differential. You could actually do house pressure if you wanted to with that. Let's talk about how you would do a combustion test. Okay, so I'm going to come back to the screen. So like I said, you're going to plug in this hose and probe. You're going to do not put the probe in a stack yet. You're going to turn on the on button on here. The unit comes on. You pick your fuel, because every fuel has a different combustion efficiency formula. And it's going to run 30 to 60 seconds. Remember, do not put the probe in a stack yet. And it's going to, at this time, it's going to calibrate that oxygen sensor, because Mother Nature always gives us 20.9% oxygen in room air. And then it's going to going to maybe zero the CO sensor if you're not in manual mode. And after that 60 seconds, it's going to come up, and then you put the probe in the stack. You hit run, and you're going to be reading your readings. Okay, you're going to watch that temperature come in the stack of the appliance, the furnace, or boiler you're working on. So you're not going to really read your efficiency until it comes up to what's called steady state efficiency, and then you're going to do that by looking at your temperature. So in a high efficiency furnace, maybe it's going to come up 60, 70, 80, 90, 100, 110, and it's going to go 120, 123, 122, 123. You're just hovering there. Okay, that's where, if it starts hovering somewhere, that's where you're going to take your test. If you're in a boiler, it might go up to like 390, 400, 401, down to 398. It's just sort of hovering there. That's where you would take your test. It's steady state efficiency. You're not going to take it as it's ramping up. You do make CO at startup in all these appliances. Okay, so that's how you take it. It's as easy as that to take a combustion test. We're going to do another poll here.
Great. So yeah, wanted to see from the attendees whether your analyzer is calibrated and ready for the upcoming season, or if you still need to do that before heating season starts properly. So it looks like it's about a 50% split. Give it a couple more seconds for everyone to answer the question. And there you go. Yeah, so it looks like 57% of you are still waiting to calibrate your analyzer for heating season. 43% of you have already done so. Yeah, so that's great. And I think, Jim, we're going to be coming up on talking about how analyzers are calibrated and some of the features that Backrack offers with B-Smart, and our replacement sensors, correct?
Okay, thank you, Matt. I'm going to talk about, so we talked about how the analyzers work. So there's your O2 sensor. We already talked about how it calibrates an error when you start it up. It says in zero, sort of, this does not zero, it calibrates. So it's going to say, this has a different millivolt reading weekly. It can change. So it might be saying, okay, while you start up, this might be 32 millivolts today. Maybe yesterday it was 30.1. So today, 32.1. So if it's 32 today, it's going to say 32 millivolts equals 20.9% oxygen. CO sensor, we want to purge the unit when we're done taking our test to get that CO out of the sensor, but it zeros at startup if you're not a manual. We have batteries. Backrack uses disposable batteries. If you really prefer rechargeable batteries, you can actually, I used to say go to Radio Shack, but we can't do that anymore. So go to, I don't know, wherever you, Walmart or something, where you would buy a recharger and rechargeable batteries. You can recharge them outside of the instrument. You're welcome to use them in our instrument. You just don't recharge them in our instrument. You can run offline power on ours as well, okay? So we went over that, okay? It's just showing you how, and you can replace your sensors as well, okay? So it's easy maintenance on products. Most analyzers now let you replace your sensors. So if your oxygen sensor goes bad or your CO sensor goes bad, just go to your local wholesaler and buy the sensor and put it in yourself. Our CO sensors, you can buy them pre-calibrated too, so you can just plug them in. And they're calibrated for a year. So, talking about calibration, if your sensor is still good, but if you asked us, and everyone here who had showed the different analyzers you have, if you asked how often do I calibrate my CO sensor, all the manufacturer would say 1 year, every year. Backrack has 3 different ways to do it. You can send it to us in Pittsburgh, and we'll calibrate it and send it back to you, and then you'll have a certificate that we calibrated it. You can buy a calibration kit. If you bought 15 units, maybe you would prefer to calibrate them yourself. The onus is now on your back, but we sell you a calibration kit. We'll show you how to do it in the manual. Take good notes, write down the serial numbers of the units and when you did it and how you calibrated, put in your files. So if anything goes wrong, you have proof that you calibrated this and it works correctly. Or we have a program called the B-Smart Sensor program. It's a calibration program. We're not selling CO sensors, we're selling calibration. And so you sign up with this and you can buy, it's actually cheaper than getting it calibrated by sending it in. You will buy this program through your wholesaler, through us, and you can say you just bought one of our analyzers, and you say, okay, I want to buy the B-Smart calibration program. You would pay the wholesaler it comes in 2 calibrations, and then they would let you put in the address of where you want the calibrated sensor to go, and then you would tell them when you want it. Well, if you just bought the unit, you want it September of 2021. Okay, September of 2021, in the mail will come a package. You open the package, it has a sensor in it. You take your old sensor out and put it in the package, take the new sensor out of the package and put it in your unit, and then there'll be a little piece of paper. Don't throw that paper away. It's a code that you put on the front, so you're calibrated. And then you just throw this, since the old sensor's in there, you seal this up. This is pre-stamped, pre-addressed. Just throw it in your mailbox, and you'll, or the post office box, and you're good. And then 2022, September, you'll get another one. You just swap out the sensors and then put your old one in that envelope, and you're good to go. And then you're under our umbrella for a year. Each time you put in that new sensor, so you'll get a certificate. It's not a cert, it's a certificate. Let's talk about printing. Okay, one of the questions I always get asked is, can I use my combustion analyzer with if I have a printer from someone else, okay? and other combustion companies, can I use that printer with the back rack unit? And the answer is no, and it goes vice versa. And it'd be just like if you had a Sony TV prior to this, and you just went out and bought an LG, you couldn't use that remote from the Sony on your LG TV. There's a different protocol that's coming out of here. Okay, if it did work, it would be a fluke, you know. So these printers have a magnet on them. They can set them there. You can have the magnet here, and then you can just hit print. It'll print out. It'll print out time, date, serial number of the unit. You can have your name up here on it as well, and it has all everything that you want on there. You can do before and after. Okay. Now we've come up with a Combustion app in both our Intech and our Insight Plus, and it works on the PCA 400 as well. In the Intech and the Insight Plus, it does it by a QR code. So actually, you don't have to have a printer anymore. Okay, a lot of people still buy them, but we have a lot of people just use the app. So you can go to your app store, either Android or Apple, download this app for free, and we don't take any personal information. You know, you just download it. There's no information given the back rack, and now you have this app. Okay, so if you're running your test, okay, and then if you hit the stop buttons because you want to freeze all your readings, and you hit this right-hand button here, it'll bring up a QR code. Then you get your phone, open up your app, and you would either do it with your pad or your phone. Just hover it over here. You can be up like almost like a foot away, and bam, everything's going to go into here. Okay, and you hear a ding if your volume's on, and then you have all the readings from that combustion process. Okay, and so that you can make a report. You can do as found or and then as left. So in this case, and you can put the name of your company on here, your technician, the name of the customers. Okay, this app even has a little place to automatically put the location. So it'll show a location like MapQuest. You touch that and it'll automatically let you know where you're at. Okay. And here's an example of one where they replaced an old furnace with a new furnace. Okay. So here the oxygen in the old furnace was 9.2, the new one is 8.5. But the efficiency in this furnace, the old one was 75. So the new efficiency is 92. So they're saving a lot of money buying this new furnace. Okay, and really the reason why is because of the heat. The old furnace had 507 degrees. It's really hot. Okay, and the new one here is high efficiency furnace, obviously. So it's a condensing furnace. It's under 125, 130 degrees. Okay, so we're condensing. That's why you have such a savings in efficiency. Okay, here's another one where we have fast found as left, and it was the improper gas pressure. So the problem here was the high CO. Okay, and so it was either overfire or underfire. They corrected the CO, the gas pressure went down to 50, and so it did change the efficiency pretty drastically. But when you corrected that gas pressure, it lowered the oxygen automatically. But it definitely lowered the carbon monoxide. Here's in your moisture trap, we want to, like I said, you want to constantly change that water when it's probably just after each use you want to look at it. Or if you're in a high moisture area, so you want to keep the track vertical, it works better. You want to keep your filters dry. So now's a good time, if you have these analyzers, no matter whose you have, buy some extra filters. You should have at least 4 of them dry on here. If it's a wet filter and you keep operating on it, it's like sucking on a wet sponge, and you're going to pull that water into your instrument. So you want to change that to a dry filter. Let the old one dry out. And when you're done testing, you want to go into a purge mode. Okay, so you can purge our instruments from a 1 minute to 5 minutes to 10 minutes, and you set that up in your setup menu. And I like at least 5. So you're going to, when you turn the instrument off, it's going to run for 5 minutes. It gets all that moisture-laden fuel out of the instrument, but also gets the CO off the sensor, so your sensor is going to last a lot longer. And then when you're done testing, disconnect the hose. So if there is water in that hose, it migrates to the atmosphere, and open up the water trap. So same thing, water would migrate out to the atmosphere, not into your instrument. Tips for extending O2 sensor life: keep your sensor dry. Keep your sensor dry, keep your sensor dry. A friend of mine, Rudy Leatherman, sent me this slide, okay? And keep it from freezing. One of the other questions we all get, is, do I have to take this in at night? You don't have to, but if you looked in specs of any of our instruments, it probably says, hey, you can take these down to 10 degrees, But CO sensors and oxygen sensors are electrochemical sensors, okay? So it's not water in there, but they will freeze at some point, especially if there's water in it, moisture in them. And by principles of contraction and expansion, it'll pop that sensor. So you want to bring it in when it starts getting cold, about the mid-20s. It's my personal recommendation. So, and here's one where someone, an oil burner, actually a wood burner, but oil would be the same. They stuck it in without taking a smoke test, and in a few tests they made this yellow filter black. Okay, so you definitely want to take your smoke test. Where are you going to take your test? These old atmospheric furnaces, you want to get back into each one of these. They don't make these furnaces anymore, but you want to take it here because it brings in room air here. So you want to get into each of those clamshells and take your test. Fan assisted here, you would come up here a little bit, put it in there and go about halfway. High efficiency furnaces, you need authority of jurisdiction to drill into there, and you definitely want to plug that up on any of these, but especially this one, we recommend drill and tap. But we do sell plugs for these. On a boiler, okay, you want to take it below a barometric. Usually in a boiler, you have a thermometer there, so you can take out that thermometer and put it in. Here's a couple boilers you can see in the school. They're 2 different boilers, they look alike. Here's one, we're on to boiler school. Actually, this is an older instrument of ours, but there's a thermometer there. We took it out, put it in there, put it in the hottest spot, and then we could tune up the boiler right there. Because in a boiler, if it's a even number passes, the stack's in the front. If it's an odd number passes, like this one, the stack's in the back, and this is the back of that boiler. So now this would be our PCA 400. We can stick it in there. We can use our Combustion app, and the PCA 400 would Bluetooth to the front. So you could have your iPad or a phone or Android unit and do the tune-up just by Bluetoothing to it. Let's talk about carbon monoxide. So I got less than a half hour here. So carbon monoxide is a deadly, colorless, odorless gas. You can't see it. You can't taste it. It's almost the same molecular weight as air, so it mixes very well throughout the house. It is poisonous, but it's poisonous in a different way. So it has no color, no taste, no odor. And the only way the human body can detect it is by symptoms. And we can get like headaches, nausea, blurred vision, fatigue, drowsiness, shortness of breath, confusion. You feel tired. You may feel fine leaving that area, and you may not. It depends how much your exposure is. And so this is very much like flu-like symptoms. So it's very hard during the winter season or any virus that we may have right now, symptoms, to tell the difference between carbon monoxide poisoning and the flu. So The way CO gets into your blood is we learned in 5th grade that you breathe in here and you have air goes into your lungs, oxygen is part of that air, and you have hemoglobin in your blood, and that hemoglobin picks up that oxygen, sends it all through your body, and then your heart and your lungs and all your organs use that oxygen, give back CO2, and you breathe out CO2. So it's a beautiful thing. We exhaust CO2 and plants do just the opposite. But if there's CO in the air, the human body, that hemoglobin, and we breathe in and CO comes into our lungs, that hemoglobin absorbs that CO 200 to 300 times faster. So now we're circulating CO through our blood and it displaces that oxygen. So that poisoning, it's not poison like arsenic, it's almost like you're drowning, you're suffocating from the inside out. So a lot of people who are victims of CO poisoning start getting like blue fingers or blue lips, and the way they treat it was with a hyperbaric chamber to kind of, the way you would do with bends to force oxygen into your blood. So, keep that in mind. There's many cases that I don't have to talk about that, people have saved people's lives because one person, like this one boiler technician went into a school district and the kindergarten classroom was had the flu for a month, and he was in there to sell his boilers, and actually the facility manager told him about it, and he said the strange thing is no one catches the flu from him, but they can't get rid of the flu. And so he had a background combustion analyzer. He went down in that room, much to the dismay of the whole school, and went in there, and I don't know what the concentration was, a very high concentration. And he's credited, they had to evacuate that school, and he's credited saving all those kids' lives, because every day they were exposed to this. And CO has like in that case, they went up to the roof, and the exhaust of the boiler was being sucked in through a pipe that went into that, the fresh air for that room. And CO, our bodies don't want to give it up. It has like a 4-hour half-life. So if you had 5% of your body had CO in it and you went into fresh air, it would take 4 hours and that would go down to 2.5. And another 2 hours would go to 1.25. It takes a long time to get CO out of your body. So keep these things in mind. Here's the symptoms of carbon monoxide. Okay, and you can just see how like at 200 you're starting to get a headache, life-threatening at 400 parts per million CO, and then you can actually at 800 you can be unconscious in 2 hours. Mind you, our analyzer is going up to 400. That's why there are codes, and a code, whether that CO is getting into the house, has very low numbers. For raw CO, maybe 100 ppm or something. You have to follow your state and local codes. And they're very low because it's such a life-threatening gas. Okay. You're going to notice on your analyzer you have CO air-free. So some of you with a back rack, it says CO and 0, means 0% oxygen. Some of you may have COAF, that would be air-free. Some of them may have COU, means CO undiluted. They're all saying the same things. What would happen is the industry is saying, like, you can really add more excess air and your CO readings going down, but you still have all those same molecules of CO. You're just diluting it. So they want to have something that takes you back to a base point, and that's CO air-free. CO air-free is just taking the oxygen out of the equation. Because if I had 100 ppm raw CO and I diluted it with 20% excess air, it would be give me a different reading than I diluted that by 50% excess air. So I could actually run a boiler, and if I knew someone was coming and test it, just add in more excess air and get rid of that, lower that CO. So they're saying, no, we don't want to do this. So they came up with CO air-free, and CO air-free takes the oxygen out. So you have to have a combustion analyzer to do this because you need that oxygen sensor. And so here's the formula. You take 20.9 minus the oxygen, so maybe you have 8%. You would take that, divide that by 20.9, and then take your actual raw CO reading, and that is CO air-free. So CO air-free is going to be something like here. If your regular CO reading says 100, and you're at, say, 6% oxygen, your CO air-free is 140. CO air-free is always going to be a higher number because you're taking that off, you're not diluting it anymore. Okay, so you know which code you're working at. A lot of times, like AGA says, you're allowed 400 parts per million CO air free. Okay, well, I would never set up a furnace in a house at 400 ppm, just regular CO. That's extremely dangerous. Usually that code's like 100. So you want to make sure if you're doing what the code is, if it's CO air free or if it's just raw CO, and then you comply to it by which CO reading you're looking at. Let's look at troubleshooting with a combustion analyzer. Here, because of the time that we have, I appreciate if you just take your phone out and take a picture of this. We don't put CO in here because actually you have to follow state and local codes. Okay, so you know, we don't have the ability to say that your city will let you have a certain amount of CO. So talk to your authority of jurisdiction or your gas company. Okay. So let's just do a mock test through a house. Okay, let's just say you got called, people have CO in their house. Their alarms used to look at, alarm went off in the house. It used to say, call the fire department. Now they say call a qualified technician. Actually, they could call, they're probably going to call someone before you, but if they called you and you went in, you want to take your first test when you walk in the door. So you want to turn your analyzer on outside, walk in, and if it's over 40, I would get the people out of the house and evacuate it. A fire department won't go in over 40, so why should you? But let's say it's under 40, because it's not going to get better as you get deeper into the house. Say it's under 40, they're going to blame the furnace that you put in. So you go downstairs, you look at the furnace. We find about, there's been studies on it, about 24% of the time it's the furnace. But the homeowner's going to blame you 100% of the time. So you go down and look at this furnace, and there's about 10 reasons why the furnace may be making carbon monoxide. So you want to test it, as we showed you where to test before. And so you can have too high a gas pressure or too low a gas pressure. So you definitely want to set your gas pressure. You can have too high a draft or too low a draft. If it's too low a draft, those gases back up and they burn fuel rich. Okay, you could have dirty burners. I used to have an old atmospheric furnace, and every year I would check it. It would be 55 ppm, somewhere to 60 ppm CO. I would take those burners out, clean them up, vacuum up, put them back in, and it would drop below 5 every year, so that scaling would come down only on the burners. Okay. So you want to check your draft, you want to set your gas pressure, you want to check the dirty burners, flame impingement. Anytime a flame touches a cold metal surface, it always makes carbon monoxide. Okay, so you want to check any places where you may have something like that. You guys that are on boiler work, you want to check the same things as well as mechanical situations. Maybe you check your combustion going up, but then you want to check your combustion going down because you may have slop in your linkage. So if those don't match going up or down, it's a mechanical problem. I was called up into Canada where a company put in 2 package boilers, both the same manufacturer, quality manufacturer, and one had very low CO under 100, and the other one had very high CO over 8,000. And well, they didn't know; they just knew it was very high. And so their unit went to 4,000 ppm, and it just loaded up. And so they blamed it on our unit. So when I was up here, I checked it out, and here at the end of the story is that and they did everything I told them, cleaned the burners, they checked the linkage, but they were new. They said there was no flame impingement. They checked the draft, checked the gas pressure. Well, here what it was it was flame impingement. And one of the burners was just slightly cocked that you couldn't see it, and it was touching the Morrison tube and made a flame impingement. And I took up my bigger analyzer, and it showed it was around 8,000 parts per million. So you definitely want to check those things. Also, if they have an old atmospheric furnace, a lot of homeowners don't see the beauty in it that we do, and they build a closet around this or a laundry room, and they shut off all the air, open the door, you test it, and it's getting fresh air. So you want to check it in the conditions that it's in. Be definitely furnaces have a problem, change your filter. Okay, so here's the things we talked about. You can make flame impingement too high or too low, draft mechanical problems, or burning wrong gas pressure. Water heaters right beside it. Let's check that. Okay, so you wouldn't check it here because these bring in room air here and to create draft. A lot of people just drill a hole here and put their probe down through there. If you don't want to do that, you could get a little piece of soft copper, make an L, make a tight connection with the rubber hose here so it doesn't suck air. Now you're only reading your CO. If you put your thermocouple down through, drill your hole, put your probe down there, you're going to read temperature as well. So a lot of times these burners in a water heater, they just get dirty. They get a lot of soot because you know how a water heater works. This is your burner here. It has a circle of flames, and it heats up and goes through this tube, and there's a diverter in there, a piece of twisted metal that slows those gases down. And the water comes in here, gets heated up, and it goes back up. I had a neighbor called me over one time, had a very good name water heater, but it was making high concentrations. Once again, it was over 8,000 parts per million, just a residential water heater. I was amazed. I've never seen anything this high. And so I told him to get his kids out of the house and let's work on this. So the problem was, at the end of the story was, he had a lot of kids, and he had a swimming pool in the back, and he was mixing his swimming pool chemicals down here in his basement and by the water heater. And anytime and they have chlorine in them, of course, and anytime you take chlorine and you heat it up, you make hydrochloric acid. So that twisted piece of metal that goes down here to slow the gases, it's hung on right up here, hangs right over here, but these little pieces of metal, like little ears, little hooks. Okay, well, that hydrochloric acid ate those little hooks, and that metal just slid right down there, and it set on top of the burner. It was flame impingement, made over 8,000 parts per million CO. Okay, so I tell you that, watch, the people put these in furnaces and water heaters and laundry rooms, and there's a lot of things going on there. A lot of bleach and different chemicals in there. So make sure they don't put bleach in a bucket and water and by the kids' ball uniforms and put them over here. Okay. Also, if you're going to work in a laundry, your commercial work, a lot of manufacturers void warranty if you're going to work in a laundromat on their appliances. Okay. There's a burner. Let's go check the wood stove. Wood has more potential to make fuel than any other, make more CO than any other fuel. Very powerful, they really pull a lot of draft in. One of the things, they can pull so much draft up, they'll actually backdraft water heaters or things. So, that you should always open a window if you're going to run a wood fireplace. So it pulls the air out of there because you're taking that air up your chimney. Now a lot of newer ones bring in outside air. Okay, so check that. Kind of play like investigator. What were they doing when their home alarms went off? Okay, we have unvented fireplaces now. Okay, I know these are outlawed in some states, and then if anyone from Canada is watching, I think they're outlawed in Canada. But check these. One of the scary things is homeowners can go down and buy these and put them in, and they may have flame impingement on them. They may not set them correctly. But really, if you read the manual on this, it says the homeowner tells them to open a window. And it's not just so much for CO, it's also all those gases that you're putting into your house. Okay, well, we talked about those gases: water vapor, CO2, heat, hopefully not CO. But that CO2 is heavier than air. CO mixes very well through the house. CO2, carbon dioxide, is heavier than air, so it goes to the floor and it's going to start building up. Very tough on a dog. Don't do a slumber party with this running. And it has a little thermistor here, a little flame. Okay, and when the CO2 gets up here, there's no air below that, and that flame shuts down, and it'll shut it off. That means that you shut off when there's no oxygen down there. So that's why you want to open a window when you run this. And this is not to be run overnight. This is intermittent, very steady. They'll clean burning if you want to check them. Okay. Wood burning stoves. Once again, they can pull a lot of draft out. I had a friend, he was running one, and he noticed every time he ran it, his front door, the foyer would get cold. So he had to actually pipe air into here. So we'd use that air to heat it up. Gas stoves. Okay. Gas stoves are not considered a heating appliance, though every year we do read about someone that uses a gas stove as a heating appliance. I do live in Western Pennsylvania. So the way you would check this, they're under a different standard, and that standard says you're allowed 800 parts per million air-free. Very old standard, written a long time ago when we had draft heat houses. But the way you would check it is it has an oven, and we're worried about that oven. You're going to run that oven, and if you're cooking, baking something for hours, or in case of Thanksgiving, maybe hours on hours. The vent for it is right here, okay? So you want to warm the stove up 6 to 7 minutes, put your probe back in there and see what the CO reading is. And this is just Jim Burke saying this is not backrack recommended, but there is a man called George Songus. If I could quote him, he would say, if this stove was making 125 to 150 parts per million, it's going to actually make 8 ppm in the house. Okay, and there's a standard for the house. You shouldn't have more than 8 ppm. It's an ASHRAE standard. So he said you can look at it that way. Okay. If you had CO undiluted, you want to look at it at more at that 800 parts per million. So I would definitely have, for a gas stove, a fume hood that took those gases and took them outside. Usually when I see these running bad, they're bad. So usually, what you want to do is you want to check the gas pressure if it's running bad. I've seen propane stoves run on natural gas and vice versa. So you want to make sure they're correct there and change the orifices if they're not. You want to check there's a flame spreader in the oven, okay, to even out the heat. Sometimes these bend and they make a lot, so you want to make sure it's replaced. And if it's bent, you don't want to, some of the older stoves bringing in air down below and bring it up. You don't want to have tin foil over here and suffocate that. So those are things you want to work out on a stove. Most of all, in a stove, you should have a fume hood and open the window if it's but I have a fume hood that's taking those gases out of the building. We tighten up our houses now more than anything, and the problem is we've tightened them up, and now we have appliances like your water heater, your gas stove, your vents in your bathroom, your dryer, regardless of what it is, and it takes air out of the house, so we can have a slightly negative pressure, and that's what this is showing you here. And so, I lost the slide here, but really, 60% of the time it comes from attached garage, okay, where you're going to get that. So, you ask a homeowner, were you running the car in the garage when this happens? They said, no. After you test all this, you go, you sure you weren't running it? Maybe not even with the garage door open? Like, oh yeah, I was, the garage door was open. So we find that a lot, but definitely 25% of the time, it would be also with the furnace and then your water heater after that. Okay, so you can check a cracked heat exchanger. It's sort of indicative of a crack. If you have don't you wish you could show a homeowner a crack like that and say, hey, there's your crack, but you can't. Very seldom can you see the crack like that. So here's a test that you can do with your analyzer. It's not 100%, but is indicative of what's going on. Since we have an oxygen sensor, you can go in here, you can turn your unit on, and here's, if you want to take a picture of how our engineering department told us to do it. Okay, because of time, I'm going to tell you how to do it myself. So turn the unit on, it's up and running. Okay, see, the problem with a crack is if you have a crack in here, 9 times out of 10, air goes from the plenum the air side through that crack into the heat exchanger. So it's not really bothering you. But it's that 10% of the time we're worried about it going out, okay, that you can get CO into your house. So we're going to turn this on, and it only has this differential in pressure when the blower's on. So what you're going to do is you're going to turn this on, turn your fan off, check your oxygen. Okay, and in case of, it really works good on old atmospheric ones. You could check every clamshell. But here you're going to check your oxygen. Let's just say, for the sake of arguments, it's 6%. Okay, then you turn your air handler on, and it makes that differential pressure, and your oxygen goes up by 0.5% or more, which is probably getting it through that crack. So if it went from 6 and went up to 6.5 or more, it's indicative of a crack, and it shows you should probably do further investigation. You do find a crack, and it's doing that with repeated testing. You can take the homeowner down and show them this, because I know a lot of times they may question you. So here in our Insight Plus, we actually have that graph I told you about. So here's where you would be running here. You turn the blower on, it's going to come up, show a higher number, turn the blower off, goes down. We're ending up the seminar here, so just a couple more minutes. We're going to do a couple questions here. One of the questions someone sent in is, what is all this rust and all this on here, this white stuff? This is like an effervescence powder, this rust. This really means you're condensing. Okay, you're condensing those flue gases, and we don't want to do that because you're going to get this. So you put your probe in a stack. What do you get? Do you see anything on here? And actually, you can't holler out, so I'm going to holler for you. And someone goes, the stack temperature is too low. Yeah, you're condensing those gases. Okay, so it's under fired. It's also, so this unit was under fired. The problem with this unit also is where you're going to get a lot of this condensation is this replaced this house was built in the south side of Pittsburgh, and the house was built in 1902. So it had a big old coal furnace. Okay, so you can see what a clean out here is for the coal furnace. And whoever installed this, it's a hydronic boiler, stuck it into the same old chimney that coal furnace used. Well, coal furnaces use big old chimneys, okay? And now these gases, they go into this big old chimney, they lose their buoyancy, and they condense before they can get out. They'll also start eating the mortar, and you'll start having bricks fall in, a picture of 3 bricks, a dead bird, and a lot of carbon in chimneys like this. And you're going to condense those gases. You're going to get that. Okay. So someone said, should we replace it? Turns out these people said, hey, the contractor replaced it right there, and he charged me $400. So I guess for $400 at a clip, he was going to replace his chimney. Look at all that carbon. Definitely shows you have a rust. You have a problem here. And I would replace that whole thing, but I would line that chimney. Okay, here's an oil burner up in New England. There's a little dead rat in the back. We always like to joke around back rack. The little rat died of carbon monoxide poisoning. So they take a draft reading, -0.01. Okay, take a combustion reading, and I know everyone's raising their hand right now saying it's too high a CO. You're absolutely right. And why is it making too high a CO? Because you only had -0.01 inches of water column in draft, okay? So it's not high enough draft. So you should have, in a furnace, you should have -0.02 to -0.04 in a draft furnace, okay? Here's one. I know you're looking at this and you're saying this probably can't happen, but it can happen in this. And this is kind of a strange situation. You're going to look at this. If you only look at efficiency, which I try to explain, you want to look at your oxygen, your CO, your stack temperature, and then efficiency. Because if you look at oxygen and you look at this furnace, you can say, wow, we have a problem here. This should not be running at 3%. If you took a picture before, you'd see that these furnaces should run 6 to 9% oxygen. And though the efficiency looks great, looks like you're a hero, you're going to start building up a lot of CO, and you're going to have problems on down the line. So you want to You want to find out why this has low oxygen, and in this case, it was an obstructed air case. And so you're just going to have a callback later on, or some trouble with tenants, end users. Here's a oil furnace. Once again, oxygen 6%, 6.1. Your efficiency is 84. Your CO is 17, well within code. Stock temperatures within manufacturer specifications. You're doing okay. Nothing's wrong. You can print it or download it to your app. Okay. It's just I got a couple funny slides I want to show you if you have a couple of minutes. Contractors send me from the road. Here's one. I think they gonna have a drafting problem. Yeah. Here's one where guy must have been a tinner, huh? So look at the water running down there. This was actually, he installed a bathroom fan. Okay. So they said, well, don't just dump it into your attic. So he dumped it into his vent. So look at the water on his bathroom ceiling, and then look at the water running down that vent. Yes, not to be good. And then here's my all-time favorite. Trainer sent this to me from the Midwest. I want to shout out a hi to you and thank you. And what this is a he was telling me that the home alarm company drilled a hole. They were running wires through the house for alarms, and then they go, wow, there's a metal pipe that goes through this house. So let's drill into that pipe. So now he goes, also everyone, always men together, and go, okay, this is, and women, because this is how we're going to do this. We're going to drill into this metal pipe, and we're going to pull our wires through there. We don't have to worry about chases anymore. And then we'll just pull them out in the attic and run them around through that where we need them. Well, he did that, and they were doing that for a while, and he did it one day to a HVAC technician. So this technician comes home and goes, what? So he turns the company in not only to the authority of jurisdiction, but he also turns them into the local news, and they were busted. So I want to thank everyone here for paying attention and listening to me. If you have any questions, Kevin's and my email addresses and our phone numbers are on our website. So Kevin does the western part of the United States. I do the eastern part. Pretty much around the Mississippi. We kind of swap a couple states in between. Thank you very much.
Thank you, Jim. I appreciate you taking the time to present this today. We did have a lot of great questions come in from the attendees. I do want to kind of touch on a couple of housekeeping things, and if anyone has any additional questions, please get those in now. If we were not able to get to your question, we will try to follow up via email. But as I mentioned, we will try to provide the charts and graphs that we had to skip over for the sake of time. We'll try to provide those via an email. And if you're looking to download the Combustion app, you can go to our website, mybackrack.com/apps, and you will see a link there to both the iOS and Android or Google Play Store. So we do have a couple questions coming in, Jim. I think we have a question from Robert, and the question is, what is the CO parts per million for oil number 2?
You have to follow your state and local codes. So there isn't a standard here. First of all, you want to look at your burner manufacturer, but where you're located is going to say you may be allowed to have 100 ppm or less. But it's so easy to get rid of from what I said. Even if it was at 80, I would work on cleaning it up, so it doesn't get worse. And then of course in oil you're going to start sooting, So, but no, we don't have a number. We don't give you a number. You have to follow your local code, your state or local code.
Thanks, Jim. And then we had a question. Someone had asked whether the analyzers will run on lithium-ion batteries.
That's a good question. We'll have to get back to them. I don't think so. I think there's a surge on lithium-ion batteries. So I think you can use rechargeable But we could get back to that person. I think that might be a surge on there.
The PCA 400, I believe, does. I don't know about the Insight or Intech.
Yeah, you're right. Well, yeah, we don't do it on the. I thought you meant if they were disposable ones you would buy off the shelf.
Yeah.
No, we use disposable on the Insight Plus and the Intech, and then on the PCA 400, you could actually, you could do it two ways. You can use disposable, or it comes with a lithium-ion battery, and you can charge that whenever you want with no memory effect. So I'm not sure if that answers that question.
So Anthony's asking if we could share any additional resources. I think, Jim, you might have had a slide with some other resources that attendees might be able to reference for some additional reading.
Yeah, we have, I think we do. Yeah, I do. Okay, here's some resources. There's actually a training company, national one, NCI. So, they do a lot of good training. ESCO also has a training company. Beckett has good manuals if you're into oil for their burner, or you could go to any burner manufacturer if you're using their burner. A lot of boiler companies have their own training on that boiler, but then here's some other ones. Just a quick look at. Nora is a good one, but NCI does good on classes as well.
Great. Now I'll try to make sure we include any links to these in the post-webinar follow-up email. Jim, we also had one quick question, and for the sake of time, we'll make this the last question. There was a question about software updates for the Intech and Insight Plus. Where would owners of those analyzers find the firmware updates, and what might they need to do to install those so that they can use the Combustion app?
Okay, well, the older units, if they have like just an Intech or an Insight, won't do it. But our ones that were made from, I think, 2012, you can. Well, that would be for the features of TuneRite and that. If you can go to our website, and we have that little UBS connection on the bottom of their analyzer. You can connect that to your computer, and you can download and update your unit. If you want to send it in to us, we could do it as well. And there'll be things on our website will help you upgrade that firmware. Okay. If you want to, you said the app. So if you want to do the app, you just go to your app store and download it from your app store. If you have an Android or an iPhone. Okay. You would just look for a Combustion app by Backrack.
Well, everyone, I again appreciate everyone taking time out of your day. We will be following up with a survey here later this week, and you can also expect to see that PDF certificate for any CEUs. Jim, as always, it's great to speak with you, and thank you for sharing all your knowledge of combustion.
If we could say one more thing here, just since it's the end of it, anybody looking to buy a combustion analyzer, we actually have a fall promotion right now. So where I talked about oxygen sensors, what we do is we actually double the life of that sensor. So if you buy a unit anywhere from now to the end of the year, at the end of that warranty would be 2 years for the Intech, 3 years for the Insight Plus, or the PCA 400 has a 5-year warranty. We will send you another sensor. So you actually have 4 years of life on the Intech, 6 years for the Insight Plus, and 10 years for the PCA 400. So that details of that are on our website, mybackrack.com.
Absolutely. Thank you, Jim. And thank you again, everyone, for attending. Hope that you have a great rest of your day. Thank you.
Thank you.
Bye.